Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. We are actually at the conclusion of our work on rocks, and today our lesson will be based on looking at the rock cycle, and I will also assign some activities for you in which those activities, after the completion of them, you will be required to actually present the work. But I will discuss that a little bit later on, and then I will divide you or put you into groups, and then from the groups you are going to start off with your planning, and then you go off, complete the work, come back ready for presenting that information as a group on or in our next lesson. But our lesson today will be basically on the work on rock cycle, and that will also conclude the work we've done so far on the information on rocks. Before we start off with the activity for today, I'd like us to look at the list of words you were given in the last lesson to look up and to also explain the definitions too. And those list of words, they were associated with metamorphic rocks. So we will go quickly around the class, and then I will ask each one of you to give your definitions, and for the rest of you, you can make corrections to those activities. We'll start from Christopher at the back, and then we'll go across to the end of the table, then to Silo, to the end of the table, Mason, to the end of the table, and etc. Okay, so we're looking at the correction now of those activities or the list of words that you were given yesterday for defining and explaining. Okay, to recap on those words again, you double check. Your task was to define and to explain the following. There were 9 words that were given. Number 1, contact metamorphism. Number 2, regional metamorphism. Number 3, metasomatic metamorphism. Number 4, dynamic metamorphism. Number 5, differential stress. Number 6, compressive stress. Number 7, sharing. Number 8, foliation. And number 9, aureole. So those were the 9 words you were supposed to look up their definitions to. Okay, Christopher, you can start.
Contact metamorphism. A type of metamorphic rock that occurs in restricted zones adjacent to igneous intrusions where heat is the primary agency and the extent of the area is affected greatly, and it depends on the size and temperature of the intrusive body.
Okay, good. The rest of you check. That information is very similar to or exactly taken from the information on the chart and the work we've done. But the rest of you check to ensure that you understand the definition of contact metamorphism. Thank you, Christopher. We move on. The next person, Bill. Regional metamorphism. Your definition.
Regional metamorphism, metamorphic rocks which are formed due to heat and pressure.
Okay, very good. I think that is also simple enough for us to understand both heat and pressure. Rebecca, metasomatic metamorphism.
Metasomatic, yes, metamorphism. It is rocks that are formed through the chemical composition of rock by introduction or elimination of chemical compounds.
Okay, introduction or elimination of chemical compounds. Then we can say it is under metasomatic metamorphism. Marianne, dynamic metamorphism.
Dynamic metamorphism is rocks formed from direct pressure.
Okay, good. That's simple and straightforward. Rocks which are formed from direct pressure. Silo, differential stress.
Differential stress refers to pressure or the force applied on the rock.
Okay, very good. It's simply the force which is applied on a rock or pressure which is applied on rocks. Compressive stress.
Compressive stress is a type of differential stress in which direct pressure is exerted on the rock.
Direct pressure is exerted on the rock. Any more information we can also include in terms of alignments of minerals, perhaps that might help also when we're looking at the difference between compressive and sharing.
There's perpendicular alignment of materials.
Okay, the minerals are aligned perpendicular to the force which is exerted. That is important for you to make note of. Thank you. We move on. The next word, sharing.
Sharing is a type of differential stress in which pressure is exerted in a parallel way, causing the body to move or slide past one another across a plane.
Okay, I think with that information, that is also straightforward. We can understand that from the explanation yesterday. Thank you. Foliation.
Foliation, the structure of the parallel alignment of the textural and structural features of a rock.
Okay, so we're looking at the alignment of the features of minerals, especially in the rocks. Okay, good. That is to do with foliation. And finally, aureoles, that's the last word given for you to define, number 9.
Aureoles are restricted zone adjacent to igneous intrusion, where contact metamorphism occurs.
Okay, very good. It's explained exactly where we would find that particular zone, and it is within the contact metamorphism, and it's also explained what that zone is all about. Okay, and that also concludes the correction of the work we've done on metamorphic rocks. We're ready now to conclude our work also, and we are going to look at the rock cycle for the conclusion of our work on rocks. Might be wondering, why do we have to select the rock cycle to look at for the conclusion of the work on rocks? Okay, if you're looking at the information presented on the monitor, and I will go through, it tells us that one of the convenient way of summarizing the relationships that exist between the 3 broad categories of rocks is such that is shown in the water cycle. So if we're looking at the water cycle diagram sums up generally the movement of water in the atmosphere. Similarly, when we look at the rock cycle, a rock cycle should also be able to help us understand the different stages in the development of the 3 categories or the 3 groups of rocks that we have looked at. So perhaps a rock cycle is a convenient and a good way to summarize the work that we have done on rocks. This representation of rock genesis or origin serves to emphasize the dynamic nature of processes within the lithosphere. So here, that information is basically telling us that to sum up our work on what we have covered on rocks, perhaps we will need to look at the rock cycle, and that rock cycle may serve as a good summary for that particular subtopic. So if we are looking at the rock cycle, what is it going to actually involve? Here it tells us that as soon as a rock is first exposed at the surface, its destruction commences. The energy for this destruction comes from 2 sources, and the 2 sources are: 1, the radiant energy from the sun, which provides directly or indirectly the heat that allows chemical changes to take place, for processes such as evaporation, and for the winds that may distribute moisture over the Earth's surface, and etc. So one of the important source of energy, which allows also for the many processes that takes place on the surface to occur in the formation of the rocks, is the radiant energy from the sun. With the sun, a lot of processes can take place. For example, the water cycle has processes such as evaporation, transpiration, infiltration, surface runoff, underground flow, and etc. All of those are processes within the water cycle. But in the rock cycle, we have also looked at some of those processes like erosion, weathering, transportation, lithification, crystallization, and etc. All of those are also different processes that you can fit into the rock cycle diagram. Okay, we move on. The second source of energy beside the radiant heat energy from the sun is the gravitational energy. And that gravitational energy brings this moisture, say for example, if we are looking at rain and if we're looking at water cycle, the energy for the rain to fall down is also contributed by the fact that gravity pulls everything down towards the center of the earth. And gravitational energy brings the moisture earthwards, again in the form of rain or snow, causes streams to flow, and other downhill processes. So we know also that because of gravitational energy, rivers would usually flow from higher land areas down to the lowland areas. We would be breaking all the rules of nature if we ever come across a river that flows from the lowland area up to the highland area. Okay, so here we're looking at those two important sources, gravitational energy and energy from the sun. And these sources of energy combine together, and both of those provide what we call the driving force for the many different processes which takes place on our planet or in our planet. So what is our task then going to be? You have a sample. Not very clear, but when you do your presentation and when you do your construction, your information is going to be clear enough for all of us to actually see. Okay, you are going to construct something similar to what is shown here. It does not have to be exactly like this, but this particular diagram is a sample of the rock cycle. Within this diagram, different processes in the formation of the three groups of rocks are actually mentioned and also shown. So there are many ways in which we can construct diagrams to help us understand the rock cycle. This is one sample. Here is a second sample or example of the rock cycle, and that's what I would want you to actually work on when you go off to your groups. A simple diagram illustrating some of the important processes which are involved in the formation of the different rocks. The igneous, metamorphic, sedimentary processes of melting and recrystallization and heat and pressure, chemical processes, metamorphism, etc., that you will also need to include. But when you include those processes, you are not going to put them anywhere you want to, but you'll have to put them in the correct place where they would come in. The third sample of the rock cycle, another way of presenting the same information. A little bit more detail, because here it is showing a lot more of the different processes that we have looked at on the three different groups of rocks. On the chart here is a sample of what I have constructed, but from the back, you might not be able to see every little information that is here. So when you are doing your construction and when you are going to be giving your presentation of the rock cycle, your work that you will put on the chart must be big enough for everyone in the class to see, and also for everyone to follow when you are going through the explanation of what you are going to come up with. The design, the way in which you decide to construct your diagram is what you are going to plan in our lesson today. And then after the planning, you go off, you do your construction, you decide also who is going to talk on what process, and then you get everyone involved. Next week when we come back, we are going to look at the presentation from the groups. Okay, I have given you the different examples of what I would like you to do now. The next thing I'm going to do before I give you the activities is I'm going to put you into groups. I would like to have at least 5 groups, only 5 groups. There are 36 of us in the class, is that right? Okay, 33? 34. Okay, there's 34 of us, and if we are going to have 5 groups, then we are going to have about 7 people in 4 groups and 6 people in the 5th group or 1 group. So we are going to perhaps divide according to how you are sitting. We have 1, 2, 3, 4, 5 rows. Okay? From those 5 rows, we are going to have those as groups. So what you are going to do now is you will have to get up and you will have to move to one table so that you are all working together. And then from those groups, you're listening, you are going to decide and choose a leader. After you have chosen your leader, the leader is not going to do everything for you. No, this is a group effort and a group work. After you have chosen the leader is going to delegate. That means the leader now will say, okay, you are going to explain this process. You will do that process and etc. depending on what you plan to actually put up on the chart for your explanation. You with me so far? Okay. Your task is to construct a diagram of the rock cycle. Your diagram must include the different processes that we have already covered. You will need a chart or 2, depending on how much information you will put. But the chart is not going to be the only thing that you will show to the class. No. In your groups also, you will have to decide on which processes you are going to involve so that each one of you has a turn to explain in a logical sequence, not all over the place, but following what you have got on your chart from stage 1 to perhaps the last stage in what you plan to come up with. Okay, so you are presenting a chart next week. On your chart, you are going to construct a diagram showing the rock cycle for the summary of our work on rocks. And you are also going to discuss how you are going to display your information. And you are also going to discuss who is going to present what information for the explanation of the chart. Do we understand that? Okay. This part of the lesson now is our planning time. We need to plan, so you will have to move so that you can face with the rest of your group members. Get a piece of paper, choose a leader, and start off your discussion and your planning. Sketch if you have to, and go ahead with your planning. 2 of you will have to move this way. 1, 2, 3, 4, 5, 6. Your group is going to be 6. 1, 2, 3, 4, 5, 6. Mason, I think I'll get you to come to this group here, the second group. So you'll have to move. And your group will have to move out this way. The best your group moves out that way. Silo, if you can get your group to move out that way, to where Renagi is. And Rebecca, your group will stay at the back there, yes. Okay, and don't forget, I will provide the charts for you. But what you need to do is plan how you are going to present your information. first of all, what your diagram would look like. And then you give it to one person to do the construction of the chart. Perhaps I'm suggesting. It doesn't have to be one person. So the job of that one person, they go off home, they do the construction. The rest of you, you'll have to decide now what goes on the diagram. And then you might say, okay, you are going to explain this process. You will do this, you will do that. But on the chart, it has to be in that order so that you can explain logically. rock, it cannot change automatically or directly to sedimentary because it will have to first of all come to the surface. But plutonic to metamorphic possible. Yes, exactly. It depends on what type of maybe activities take place there. If it is a volcanic activity, it might come up quickly with together with the flow, magma and all that, or tectonic movements, folding, faulting, displacements. So it really depends on the rate of plate movement, perhaps. If we're looking at landslides, you're looking at earthquakes and faults and cracks, which are sudden, rapid. It can be quick, or it can take millions of years, depending. Yes. When you are constructing your diagrams too, you don't have to make it so complicated. You can make a very simple diagram showing the cycle, and then the stage comes in, but it has to be big enough. And the stage maybe, or the processes, you can explain. So you will say, okay, between this and that, this is what happens first before the next stage. And so forth. What do you have this period? Maths. Okay. Okay, let's or we are going to actually go off with that information now, and you are going to ensure that your group is actually ready for the presentation of the rock cycle on Monday. The group leader, you can come and pick up the chart for your rock cycle diagram from me. I hope your planning is going well, and that you should be, or you will be ready by Monday with your presentation. Okay, that will also bring us to the end of our lesson. Class, if you can now stand up. Where you are. Okay, to the pilot teachers, our keyword for lesson 59 is cycle. Good afternoon and thank you, students.
Hey.
actually go off with that information now, and you are going to ensure that your group is actually ready for the presentation of the rock cycle. The group leader, you can come and pick up the chart for your rock cycle diagram from me. I hope your planning is going well and that you should be or you will be ready by Monday with your presentation. Okay, that will also bring us to the end of our lesson. Class, if you can now stand up. Where you are. Okay, to the pilot teachers, our keyword for lesson 59 is cycle. Good afternoon and thank you, students.
Hey.